so there is, we're going to simplify. We're going to add and subtract like radicals. The first video was taking a look at what a like radical is. We're going to, if we wanted to add and subtract radicals, we had to kind of take a look at what we can add and subtract. We can add and subtract like radicals. And we were given in the previous video things that were like radicals, things like this, square root of 5 plus square root of 5. Well, those are like radicals because they have the same they've got the same radicand inside the house, same stuff inside the house. They got the same key to get inside the house, same index. So these guys could be added up, and if I give you something like that, well, we can do those all day. But the problem is that sometimes they're not going to be as easy as that. So they might be something we might have to simplify. So if we take a look at square root of 4, we've got to simplify that. Square root of 4 is 2. Square root of 9 is 3. Square root of 8, oh shoot, it's square root of 4 times square root of 2 because we separate and conquer. We rewrite whatever's inside here as a perfect square times something else. Square root of 4 is 2 square root of 2. This square root of 8, if it can't be rewritten, or sorry, if it's trying to be added up to something that's the square root of 2 or subtracted from or something like that, that can't be done without first simplifying it. So we've got to simplify sometimes. Square root of 18 we rewrite as a perfect square times something else. 18 is 9 times 2. 9 is a perfect square. Square root of 9 gets its own house. Square root of 2 gets its own house. We've got 3 square root of 2. These guys could actually be added up. As they're written up here, not. But as they're rewritten down here, these are like radicals. So the red and this black square root of 2 square root of 2 could be added or subtracted. And that's the whole idea of this section, is to rewrite in terms of a perfect square before we have to, or before we can add or subtract. Alright, add or subtract. The only way we can add or subtract is if we've got like radicals. These are not like radicals, but maybe we can rewrite this as a perfect square times something else. Sure enough, it's 4 times 5, because this square root of 20 is, let's see, I'll rewrite this in blue. Square root of 20 is square root of 4 times square root of 5. And already we've got a square root of 5 here and a square root of 5 there. We're on the right track. Square root of 4 is 2 square root of 5. 7 square root of 5 can't be simplified, so I'll just drop that guy down here. I've got addition drops down as well. 2 square root of 5 plus 7 square root of 5. Now they're like radicals. We can add them up. 2 plus 7 is 9. Square root of 5 stays the same. Add these guys up? No, but we can rewrite maybe in terms of a perfect square times something else. Simplify this as square root of 25 times square root of 2. Square root of 25 is 5. Square root of 2. Square root of 8 cannot, well, it's not the same. It's not a like radical, but can we simplify it? Yeah. It's square root of 4 times square root of 2. Square root of 4 is 2. Square root of 2 is still inside the house. Minus comes down and drops down between them. 5 minus 2, now these are like terms. Sorry, like radicals. 5 minus 2 is 3. Square root of 2 stays the same. Done. Alright, what else do we have? Can we add these up as they stand? Right? No. Because we've got a square root of 18 and a square root of 8. They're both square roots, but 18 is different from 8, not like radicals. We've got to simplify. 4 square root of 18 is, well, let's see. Square root of 18 is what we've got to attack. So we've got to rewrite that 18 as square root of 9 times square root of 2. 4 is still there. Remember, it's all multiplied together. 4 times square root of 9 is 3. Keep things in columns helps. Square root of 2 stays as square root of 2. 4 times 3 is 12. Times the square root of 2 is what this simplifies to. And I will bet there's a square root of 2 in here. Square root of 8 is 4 times 2. 4 times 2 gives us 8. Separate and conquer. I got 2 square root of 2. I got 2 square root of 2. From here to here it didn't really change because we couldn't simplify it any further. Now I've got a plus sign between them. 12 square root of 2 plus 2 square root of 2 gives me, they are like radicals, so I can add them up. 14 square root of 2. Done. Alright, let me see if I can do this in my head and see if we can give you the answer and make you work on it. Negative 2 square root 2. I'm going to guess that's the answer, and I'm pretty sure that's right. That is the answer. Alright, so basically for this page, we were given stuff that was not in like radical situation, but we had to convert into like radicals, and then after we convert to like radicals, then we can add or subtract as indicated. Whew. All right, let's take a look at some of these. These are even more and more complicated, but we can take a look at them. I don't know about we can do them. Any like radicals? No. I got a square root of 3, I got a square root of 27. They're all square roots, but this is 3x squared, there's 27, there's 3. Let's see what we can do with this. I got a negative 4 times square root 3 square root x squared. I'm just going to simplify this guy and move on to that guy and move on to that guy to see if we can simplify. I got a negative 4, square root of 3 is square root of 3. Square root of x squared, square root of a perfect square means the base x comes outside the house. Alright, so this can be simplified as, and pay attention to the fact that we've simplified square root of x squared to x. But that x is not inside the square root of 3. If you get kind of lazy and kind of extend that square root out beyond, that x might, you might confuse the fact that that x might be inside that square root house, so don't do that. Now let's combine everything in the front yard. Negative 4x square root 3. There's our first term. Second term, I'll change to green. Let's see, I've got an x square root, 27 is 9 times 3. X square root 9 square root 3 x times 3 square root 3, and we'll make that a 3x square root 3 just to make it prettier, because usually the numbers come in front of the variables. Alright, how about this guy? Well, you know what? Square root of 3 can't be simplified, so I'm going to just drop this guy down here to my last line and say I've got 5x square root 3, and I got a plus sign there, and I'm going to drop that minus sign there, and this guy becomes negative 4x square root 3. Alright, all these guys simplified to like radicals. I got square root of 3, I got a square root of 3, I got a square root of 3, and now all we do is just simply add up our coefficients. Negative 4x minus 3x plus 5x is negative 7x, plus 5x is negative 2x square root 3. Done. And all I did was simplify to get down to here, and then combine like radicals here. Alright, let's do one more example, I guess, and then maybe give you some answers to work towards. A square root of a to the 8a to the 5th, square root of 2a to the 7th, square root of 9a. You know what? We're leading towards the fact that maybe we can get these to be like radicals, but right now they're not. So let's simplify. This guy here becomes a times square root 8 times square root a to the 5th. Yikes. A lot of stuff here. A times, that's an a, square root 4, square root 2. A to the 5th is square root a to the 4th, square root a. This is an a. Square root of 4 is times 2 times square root of 2. A to the 4th simplifies as square root of a squared squared, so the a squared as the base comes outside the house. Square root a is inside the house. Let's make this blue term, all this stuff, prettier by saying combine the stuff that's outside into the front yard. So a in the front yard is outside the house, outside the square root sign. A times 2 times a squared is 2. A squared times a is a cubed. Outside the house. Inside the house is square root of 2 times square root of a is square root of 2a. Remember, we can combine and conquer. We can separate and conquer, but we can also combine and conquer. Here, we separated and conquered, but down here, we can also combine and conquer. Put this all together. Alright, middle term I'm going to make green. I'm going to say that's a 6 square root 2 square root a 6 square root a. Let's see, this would be 6 square root 2 times a square root a. Outside the house is 6 and a. This would be 6a. Outside the house times inside the house, square root of 2a. And I'm just going to drop down my plus sign right there. Last one, last term, I guess, is plus Square root of 9a, well, let's see, square root of 9a is square root 9, square root a. Square root of 9 is 3. Square root a is square root a. I got a plus sign that drops down. This is now simplified about as far as it can go. I got a 3 square root a. This plus sign drops down to be a plus sign right there. Alright, now combine like terms. This, the blue and the green are like terms. This red is not a like term. But we can combine these guys. Oops, sorry, this should be an a to the 6. Yikes, I'm sorry. That a to the 6. Sorry, should be an a. Let's see. A cubed squared inside a square root. And then that should be an a cubed outside the house. A cubed outside the house. Because square root of a to the 6th becomes a to the 3rd. A to the 3rd is outside the house. That's an a. Instead of an a, it should be an a to the 3rd. Alright, now the blue and the green can be more easily combined because they are like radicals, and we can add up our coefficients. 2a cubed plus 6a cubed is 8. A cubed outside the house, square root of 2a inside the house, plus 3 square root a inside the house that doesn't combine with anything else. And there's our answer. A little bit longer, but you know what? These two could combine. This one couldn't.